Hi, how's it going, everybody? My name's Will Adams. I'm in Professor Durande's Physics 112 class, and today I'm here to talk to you about a new method to determine the amount of calories that an individual can burn during specific exercises and the effects that these specific exercises have on the human body. So, with that being said, the reason as to why I chose this topic to present, I'm really into fitness. It's a big part of my life. It's always been a big part of my life growing up, playing sports and whatnot. But every day, people are always trying to figure out better ways, more efficient ways to burn calories, exercise at a quicker rate. And there is a new method out there in which you can determine just how many calories to the 0.00 amount that you can burn during a specific amount of time, no matter what you're doing. You could be sleeping, standing, doing what you guys are doing right now, or running a marathon. So with that being said, this is just a little overview of the different bulleted points I'm going to be covering. The MET equation, which stands for metabolic equivalent of task. And then we'll get into the number of calories burned during specific exercises in the gym and some other exercises that are out of the gym, outdoor activities. And then I'll go into further detail on how the MET equation relates to every single person, no matter what you do every day, no matter what your work life is, routine, it will always relate to you. And then throughout the presentation, I'll go over the positive and negative effects that these certain exercises have on the human body. So, what is an MET? Like I said, an MET is a metabolic equivalent of task. That's what it stands for. But the MET is a certain numerical value that is given to various specific exercises, such as doing a pull-up in the gym. This certain numerical value is sort of graded on the intensity of the exercise. So the higher the MET value is, then the more intense that the exercise is, either cardiovascular-wise or just overall intensity. So using this value helps to determine the number of calories that the individual burns over time. This, like I said, it can be used for hundreds of different physical activities, and it can also be used for many different activities that many people would not consider working out or a sport. With that being said, this certain equation helps to show just how much energy the individual is exerting every single day. And this slide just goes into a little bit more detail of what the MET is from more of a scientific basis instead of a conceptualized basis. So the MET, it's a unit used to estimate the amount of oxygen that the body is using during a given amount of time. As you can see on the right one MET is the energy expanded while being at rest. And as the number goes up, 4 METs is 4 times the amount of 1, so 4 times the amount of energy expanded at rest. And as you can see on the left screen, 3 to 6 METs is considered moderate intensity, while anything over 6 METs is considered vigorous, high intensity based exercise. And this is just a general sort of chart of the certain exercises that I'll be going over. Except for the last 3, I just kind of added those in to just give you a little, example of some of the exercises that are in the roofing. Who would have thought? Squats, I'll be going over squats, pull-ups, running and sprinting. The certain example for that one is at specifically 14 miles an hour, running a marathon. And so there's just certain values and numbers that are associated with those certain exercises. So the MET equation, it's a specific derived equation in which, so you take the MET value that is given for that exercise, and then you multiply it by a constant 3.5. I don't know exactly why it's 3.5, but that is just how it is for every single one. Then you take those two values, and then you multiply your body weight in kilograms. You take those three values, divide it by 200, and then multiply it by the duration of the exercise in minutes. So for you guys right now, just sitting, listening, not talking, that's associated with an MET value of a 1.5. So obviously that's very, very low intense activity. However, it's considered exercise. It's considered an activity. So with that being said, no disrespect for anybody who weighs possibly 165 pounds. During the duration of me talking for 5 minutes, you'd burn approximately 9.83 calories. So it's just one small example. I had put in a little link down there at the bottom. It gives 250 plus MET values for just numerous different exercises. So the first exercise I'm going to be going over is squats. And squats is one of my favorite exercises. I love doing them. I don't know. A lot of people hate them, but I like them. So for this specific exercise, with squats, you can do them at a more high-paced, higher rep, lower weight. And then on the flip side, you can use squats with slow, explosive effort with a higher amount of weight. That's what we'll be using for this one. That is associated with an MET value of 5.0. And for this example, for somebody weighing 135 pounds and squatting continuously for 5 minutes, they would burn approximately 26.81 calories in 5 minutes. And then our second exercise is pull-ups. And for this one, I specifically wanted to use the pull-up example at a faster pace, higher intensity. So somebody who's just going for a lot more reps in a certain amount of time, that's associated with an MET value of 8.0. So as you can see, the difference in the intensity, however, this would be for somebody like me. I weigh 185 pounds, and if I were to complete this many pull-ups or X amount of pull-ups in 2 minutes, I would burn approximately 23.52 calories in 2 minutes. So in 2 minutes compared to 5 minutes, you burn roughly nearly the same amount of calories. This difference, there is a difference in weight, as 185 is a lot more than 135. However, the increase in MET value is going to create a sort of a more high volume atmosphere, and you're going to burn a lot more calories in a shorter amount of time. So some of the effects that squatting, positive and negative, have on the human body are, excuse me one second. Squatting, a lot of the positives are they incorporate several different muscle groups, not just in the lower body, but also in the upper body and mid-body, quadriceps, hamstrings, glutes, abdominal muscles, all the way up into the rear deltoid muscles and the biceps. So this sort of full body environment tends to create, you tend to burn a lot more, exert a lot more energy from the entire body. It also, I mean, squats are, they tend to increase a lot more muscle mass at a very quicker rate. Some of the negatives, though, they can be very taxing on the joints, on the ligaments, on the cartilage, especially in the knees. It's not technically a very orthodox exercise, so it can be pretty cautious. Pull-ups, positives, just like squats, they incorporate a lot of different muscle groups in the back, the latissimus dorsi, the trapezius muscles that are on the neck, including the rotator cuff muscles, the rear delt muscles. And pull-ups are not technically, but they're usually more of a cardiovascular involvement exercise, so they really get the respiratory system going. And then our third exercise, we're going to get into some outdoor exercising, so marathon running. Marathon running, as you can imagine, it's very, very cardiovascular taxing. It's very, very enduring. very tough to, I mean, only certain people can do it. But the MET value for running a marathon is 13.3, much higher than the previous two. The individual on the right is Dennis Cometto. He is the official world record holder for the marathon time for males. And he ran it in 2 hours, 2 minutes, and 57 seconds. He weighs approximately 121 pounds. So he's the example that we will be using for this one. And as you can see, we'll take his weight in kilograms, divided by the amount of time, and he burned a considerable amount of calories in 2 hours. Sometimes that's more than what people eat in an entire day. So you can tell, you can burn a lot of calories running a marathon. Our next exercise is sprinting. Now, sprinting involves it's a lot more revamped exercise in the cardiovascular system, so it has a very, very higher MET value of 23. Now, for this specific example, this individual is running at 14 miles per hour. That's what equates it to an MET value of 23. And that also equates to finishing a 1 mile or 1,600 meters in 4 minutes and 18 seconds. So for somebody weighing 180 pounds, they would burn approximately 144, 145 calories in just 4.3 minutes. So when you compare that to running a marathon, sprinting does tend to burn a lot more calories, a lot more in much, much quicker time. No matter what your weight is, I mean, the MET value is so much higher that you just burn so many more calories in such a shorter amount of time. Some of the positives and negatives of running a marathon, we'll get into the positives first. Running a marathon or just long distance running in general helps to lower your cholesterol significantly, reduce your chance of heart disease, speed up your fat-burning metabolism, and it's obvious it's a massive exertion of calories. But with the negatives, however, massive dehydration, massive loss of fluids, electrolytes. A lot of people, once they finish the race, would endure undisclosed injuries such as torn muscles, stress fractures in the shin bones, ligament issues, maybe in the knees, just from the constant pounding on the pavement over and over again. It's very, very taxing. And what I found really interesting was a lot of runners who finished marathons had problems with their explicit and implicit memory, as if they had damage done to their hippocampus in their brain. The explicit deals a lot with short-term memory loss or whatnot, so a lot of these marathon runners would have issues remembering what they ate for lunch the day before. But on the flip side, they would have a heightened sense of implicit. So their unconscious thoughts would start to spiral as if they were a schizophrenic patient or whatnot. So that's most likely due to the massive loss of nutrients necessary for proper brain function. And then from there, we'll get into, how the MET equation relates to all of you. As you can see right here, I just have a little chart. There's an MET value for cooking, sleeping, walking, or carrying a child. It's for literally everything. You can calculate how many calories you burn, just as long as you know how much you weigh and how long you did it for. And this really helps to give people who may not always have time to go to the gym or go out and run. It really gives them a sense of, oh wow, okay, I'm actually burning this many calories, a day and whatnot. But it's pretty interesting. It's a pretty interesting thought. So just to conclude what we talked about today, the MET equation helps to show individuals can exercise and burn calories without technically working out. So like I said, for the average person who most likely doesn't have time to go and work out and exercise, it gives them a sense of, okay, well, I'm actually burning this many calories and I didn't really realize it. The MET equation helps individuals to find the types of exercise that fit best for them. Some people need to gain weight. Most people would like to lose weight. And this equation kind of helps to show which exercises work best for them. Like we were saying with the squat and the pull-up had, for that specific one, had a higher MET value. So maybe somebody who is trying to build lean muscle and burn fat percentage off their body, that might be more particular to their goals. And last but not least, the MET equation is kind of like a new age calorie counter. It's very to the T, it's very accurate, so it does help to really count those calories for whatever is suitable for you. But yeah, so that's my presentation. Thanks for letting me come up here and speak. And yeah, does anybody have any questions? Well, yeah, yes, usually, but that's for the marathon runner, that's just for an extreme situation. I mean, only certain people can do that, but that was just for that kind of specific example. If you were to go in the gym, or if you were to just go and exercise in a gym, you could figure out how much you burn for that much amount, and then you can also count however many calories you eat a day, so you could take that amount and minus it from whatever you burn to, yeah, I mean, that's how much you retained in the end. Well, so I guess an example for that would be squats. So the 5.0 MET value was associated for someone with who's using a lot more weight, which pertains to a slower, more explosive movement. So that would pertain to a higher amount of weight that they're using. And then I think the MET value for doing squats at a higher pace, so lighter weight, less explosive, was about 8. Same as the pull-ups. So that does pertain to the amount of weight that you use, but it doesn't have to be so specific. It's just kind of, it's slightly generic. However, it does pertain to higher weight and lower weight exercises. I would not know. I would not know that. That's a good question. No, well, I would think of it like this. So if you were to go and do a set and you timed how long you did it, then you could figure out how much calories you burned in that specific set. So yeah, and then in total you could take however many sets you did and then add it up. So that would work for that. Well, that's kind of tough. So you're saying if somebody was 185 with a higher body fat percentage than somebody with lower? I'm not exactly sure if it takes that into account, but I would assume that if somebody were to be a lower body fat, that they could most likely move the weight at a higher, more rapid pace than somebody with a lower body fat, just because that factor kind of interferes with how fast your cardiovascular system can go, just how endurance you are. So I think that would interfere with the MET value. Maybe if you did have a higher body fat percentage, you were the same weight, you would. I would. It's kind of just a prediction for me. I think it would be a lower MET value for that person, but I'm not. I'm not entirely sure on that. I'm not sure if it really takes that into account. I did not, I know there is, but this was the one that I found that was the most accurate to the .00. There was one other one, but it was very, very simplistic. It didn't seem so accurate. It didn't take enough factors into account. But I can't remember it off the top of my head. Right. Right. There's even one for sleeping or watching TV. Yeah. Yeah. I mean, paying attention for a long period of time, and then I guess when get a fish on the reel.
Is there an app that would be more convenient to like put everything store all the data completely, or?
I know there's an app that can help count how many calories you eat, but I'm sure there is one out there. I bet just one specifically associated with MET. Just if you put your weight, how long you did the exercise, I bet it can give you an easy calculation. I bet you there's something out there for that. I wouldn't know that, but the highest one that I saw was the marathon run, or no, the sprinting was 23. That was the highest that I saw, and I feel like that would probably be the highest because, I mean, you're running at your body's maximum capacity. It's maximum. You're putting it to the max. So that's the highest one that I saw, and I went through 2 different lists. Through the link that I put on the other page was the highest one that I saw in there, and it was the highest one that I saw in this other one. So, yeah. Are there any other questions? Yeah. Well, it was marathon running that had issues with the explicit and implicit memory loss. However, actually, I'm sorry, I never actually went over the positive benefits of sprinting, I don't think. Well, some of the benefits were actually a heightened sense of memory retention when it came to sprinting. Also, natural increase of testosterone production, libido production in men. It's also good for increasing muscle mass. So, like what you asked, it actually helps. Sprinting actually helps to produce a better memory retention as opposed to marathon running or long distance running. Alrighty, I think that's it. All right, thank you.